transport layer. As the name indicates, it will transfer over data from one source to other destination. So the layer 4 is responsible for end-to-end communication between two devices. This includes taking the data from the session layer and breaking it into the chunks called the segments before sending it to the layer 3. Because as a whole packet, it will be difficult to send from source to destination, and there will be chance of errors are more, so we have to divide over data into the chunks. So the transport layer on the receiving device is responsible for reassembling the segments into the session layer can consume. So they are not only breaking the packets into the chunk, also they have to reassemble that segments to make a packet. So we have to deliver that to the session layer. So the transport layer is also responsible for flow control and the error control. If there is any error, they have to identify that error and send the error message. So the flow control determines an optimal speed of transmission to ensure that the sender with the fast connection. The transport layer performs the error control on the receiving end by ensuring that the data received is complete and requesting a retransmission if its data was not correct. The network layer is responsible for facilitating data transfer between two different networks. If the two devices communication are on the same network, then the network layer is unnecessary. But when we are communicating from one network to another network, so that network layer will work and it will breaks up the segments from the transport layer into the smaller units called the packets, and on the sender's device, it will reassemble these packets and send to the receiving device. So the network layer also finds the best physical path for the data to reach its destination. So we can say that it will find the shortest path to send the data from source to destination, that is known as the routing. Data link layer. The data link layer is very similar to the network layer, only that the difference is that the link layer facilitates the data transfer between two devices on the same network. So network is responsible for the different type of networks, but data link layer will be responsible to send data within the same network. As we know, the network layer will be active when we are sending data from to the different network. So the data link layer will work in the same network. So it takes the packet from the network layer and breaks them into the smaller pieces called the frames. Like the network layer, the data link layer is also responsible for flow control and the error control in the network communication. Now the physical layer. This layer includes the physical equipment involved in the data transfer, such as cables and the switches. Like we can say that physical components of the network. So this is also the layer where the data gets converted into the bit stream, which is a string of ones and zeros. Now, how the data flows through the OSI model. In order of human readable information to be transferred over a network from one device to another, the data must be traveled down to the 7 layers of OSI model on sending device, and then it will travel in the reverse order from layer 7 to the layer number 1 to when it will be on the receiving end. TCP IP model. The OSI model we just looked at is just a reference logical model. It will be a basic model, or we can say that it will makes the clear functionality of over network, but it is not the physical model, as it is very complex and implementation of that will be very difficult. So it was designed to describe the functions of the communication system by dividing the communication procedures into smaller and simpler components. So TCP IP model was designed and developed by the Department of Defense in 1960s and is based on the standard protocols. So it stands for the Transmission Control Protocol and Internet Protocol. So it is the concise version of the OSI model. Like we have combined different layers and we converted 7-layer model to the 4-layer model. The first one is network access layer. This layer corresponds to the combination of data link layer and the physical layer of the OSI model. So it looks out for the hardware addressing and protocols present in the layers allow for the physical transmission of data. And also it will be responsible for error checking. So the both task that we have to done on the physical layer, and the data link layer will be done by using the network access layer. Now the internet layer, this layer parallel to the function of OSI models network layer. It defines the protocol which are responsible for logical transmission of data over the entire network and from one network to another network. Host to host layer. This layer is the combination to the transport layer of the OSI model. It is responsible to end-to-end communication and error-free delivery of the data. Now the application layer. This layer performs the function of top three layers: session, presentation, and the application layer. So it will be responsible to read the data from the user, then it will convert that data into the language of the transmission and make a connection in between the source to destination computer. So it is responsible for node to node communication and controls the user interface specification. That was the responsibility of application layer. Now, why we are using the computer networks? The computer network have the variety of uses that many would see the essential today, including the following: file sharing. As we know, we are sharing each and everything with one another by using the internet and the network. So the file sharing is the most basic thing that we are using. We are using by using a computer network, which enables user to share data files through a network. Now the application sharing, we can share different type of application and different type of software by using the networks. Hardware sharing, we can share the printers, scanners, and other hard disk by using the network. So we can share the centralized sources, and there is no need to give the separate printer to each and every person. We can utilize one printer for 10 to 20 persons. Now, client server model, which enables data to be stored on the server where end users' devices or the clients can access their data. And we can also use servers for the cloud computing also. Voice over IP, which enables user to send the voice data through the internet protocols. Communication, which can include the video, text, or the audio things that like a call, we are making a communication. E-commerce, online buying and purchasing, selling, gaming, which enables multiple users to play together from various locations. How computer network works? As we have discussed different components, now we will summarize that thing. The computer network operates using the varying set of hardware and software. We have discussed these hardwares and the softwares. All the packet switched network use TCP IP to establish a standard mean of communication. So all the computers will follow the same protocol so they can communicate with one and other. So each endpoint in the network has a unique identifier that is used to indicate the source or the destination of the transmission. Like we can say that we have assigned the unique addresses to each computer. So we can identify the source and the destination for the communication. If we have not assigned a unique identity to each computer, it will be difficult to make the identification to which or to whom we have sent that address. So identifiers include the node IP address or the media access control MAC address. So sometimes we are locating the logical addresses or the physical addresses. So endpoint nodes which are used for routing purpose include the switches and routers, servers, personal computers, phone, network printers, and other peripheral computing devices, as well as the sensors. So these are the components that must be available when we have to make a network. A network's capability is how much traffic the network can support at any one time while still meeting service level agreements. So we can say that like on the roads, we have the capacity of the transmission. So same in the network traffic, we can send limited data from source to destination. So the network capacity is measured in terms of bandwidth. So bandwidth is quantified by the theoretical maximum number of bits per second that can be passed from a network device from source to destination. Types of network. Types means how much the computers has the capability, or we can say that the range of the computer network. So the network are often categorized by the wired or wireless transmission technology they support, as well as the scope of their domains, like how much area, physical area, is covered by over computer network is the category of the type of computer network. The first one is local area network, that we can say that which interconnected endpoints in a single domain, like within a building. In contrast, wide area network, which will interconnect the multiple landsmans. So metropolitan area networks, we can say that that work be at the outside the city or outside the country. So the example of wide area network is the internet. And the metropolitan area network, like whenever we are shifting from our network from one building to another building, so then we have to use the metropolitan area network, so that we can say that that has the that covers the geographic area within the city. Now the storage area network, which interconnect the storage devices and the resources only. Personal area network, like network that we build at inside our homes by using different type of devices that we are using. Wireless local area network, sometimes we are using wires to connect over computers, but sometime within the building we are utilizing the wireless communication, so that is known as the wireless local area network. So these are the different types of computers. Now network topologies. Topology refer to the arrangement of the computer or arrangement of the nodes or the devices. So, and the connection on your network are physically and logically arranged in a relation to each other. So there are several different types of network topology, and all are suitable for different purpose depending on overall network size and according to our objective are the over purpose. Now, types. First one is star topology. As the name indicate, it will work. It will looks like a star. We need a central device, and all the devices will be connected to that the central device. That can be a hub. That can be a switch, and we are using different type of cables, or we can use the signals to attach our computers with that central device. So the star topology, the most common network topology, is laid out so every node in the network is directly connected to the central hub by using the coaxial twisted pair cable or fiber optic cable. So acting as a server, the central device nodes manage data transmission as information sent from any node to on the network has to pass through the central one to reach its destination. So it functions as a repeater which helps to prevent the data loss. So it will also catch the signal, so it will make the signal stronger. So that is the most commonly used topology. Most of the in most of the lands and in the houses we are using that topology. So that is the physical look of that topology. Now the bus topology, as the name indicate, a single wire will be used and all the computers will be connected by using that wire like a bus. In bus, we are attaching different seats. So in a single route, we are attaching different nodes. So a bus topology, in that topology, all the devices on a network along a single cable running in a single direction from one end to the other end. So which is why it is sometimes called a line topology or a backbone topology. So data flow on the network also flows the route of the cable moving in one direction only. So it is the simplest topology. Attaching the computer in that topology is very easy. And but if the wires will be disturbed, we will not be able to do the communication. So that is the look of the bus topology. Now the ring topology, like a round circle, we are connecting the computers like a ring or a circle. So the data can travel in one direction only, or sometimes we can send the data in the both direction with each device having the exactly two neighbors. So one will computer will travel, send the data to next computer, and next will send to the next, and like passing thing from one person to another person. So if there is one of the computer is not working, all the network will be get disturbed. So that is example of ring topology, look of the ring topology. Now the dual ring topology, a network with the ring topology is half duplex, meaning data can only move in the one direction at a time. But when we are using the dual ring, it will travel the data, or the data will be sent in the both direction at the same time. So that will be full duplex, adding a second connection between the network nodes. One is to send the data, and the second one will be to receive the data. So both direction will be followed by using the dual ring topology. Now the tree topology, like a central device has the branches, and the branches also have some other nodes. So the tree topology structure gets its name from how the central node functions as a sort of trunk of the network. So every trunk has different branches. So every node has different branches with nodes extended outward in a branch-like fashion. So however, where each node in a star topology is directly connected to the central hub, the tree topology has a parent-child hierarchy to how the nodes are connected. So, and there is different hierarchies inside that. So those connected to the central hub are connected linearly to other nodes. So two connected nodes only share one mutual connection. So because of tree topology structure is both extremely flexible and scalable, so it's often used to in a wide area network. So that is a look up over tree topology. Now, network infrastructure. We have studied how network works, the components of network, topologies, protocols, types of network. Now, infrastructure. Infrastructure is a broader collection of the fundamental components that work cohesively to run an IT network, and is a critical part of an organization's IT infrastructure. IT network means organization geographically distributed of IT system interconnected to exchange data and comprising the components of interconnected IT systems and their interface with the supporting data and communication network. So we can say that the environment in which we have made the networking, and we are transferring over data from source to destination, from one branch to another branch, from one system to another system, that is over network infrastructure. So the simplest form of the network infrastructure typically consists of one or more computers, like a network or internet connection, and a hub to both link the computers to network connection and tie the various systems to each other. Now, when we are utilizing the best thing, best protocol, best hardware components, software components to build a environment inside our organization, that is known as our network infrastructure. Now, what does a network infrastructure consist of? That is mix of hardware devices, software application, and network devices that we have discussed in our previous slides. Now, the hardware infrastructures includes routers, switches, hubs, repeaters, gateways, bridges, and the modems. So according to our requirement, we can use any of the network infrastructure. Software infrastructures include the monitoring and management tools and the operating system. So according to our need, we can utilize different type of operating system, and different type of softwares can also be used. Network services include the networking protocols that must be universal for all the computers, because we have to make a communication in internationally or worldwide. We have to do the worldwide communication. Now, network infrastructure design can help you to plan how to implement, monitor, and manage an IT network, how we can smoothly run over network, and we can expand over network, and we can update over network. So we have to choose a design that can be flexible, that can be according to our need. So design can be created after identifying the operational requirements in terms of capacity, bandwidth, quality of service, security, and flexibility. So we have to judge or analyze all our demands inside the organization, and then we have to go move towards the design. So the network infrastructure design can help you to plan an IT network more efficiently. What is the network infrastructure management? Now we have established a network, and now we have to manage that network, update that network, and monitor that network. So the network administrators implement network infrastructure management practices to ensure the network operates optimally by identifying the performance bottlenecks, problems, and determining the need for scaling to support the growing business operations. Like we have to increase the bandwidth, we have to increase the clients inside the network, we have to make our servers more powerful, and we have to upgrade our technology, we have to upgrade our operating systems. For every purpose we need a network administrator that is responsible to manage and to upgrade our network. So overall network infrastructure management focuses on the 5 points. The network infrastructure monitoring, we have to monitor or look after either our network is working properly or not. So it is a continuous system. We have to monitor and generate the reports. For example, our router may be receiving more traffic than it can handle, and sometimes it crashes, so impacting network availability. So we have to manage the network traffic. Configuration management, this focus on ensuring the network devices are configured with the best practices, upgraded or replaced when needed. Is every any device is making problem, we have to replace that device. Usually, network administrators control the automation tools to track the managed configuration changes more effectively when managing more extensive IT networks. If we have multiple hundreds of the clients, then we have to use the different devices and different softwares for that monitoring or for that configuration management. Now, performance management, this focus on analyzing the network and maintain a required network performance level to ensure business operations are not negatively impacted. So we have to check the bandwidth, we have to check either the speed is accurate over all persons are connected to over network or not. So some critical metrics relevant to performance management include the available network capacity, bandwidth, etc. Now, fault management. If there is any error occurred and the internet is not responding or the network is not able to do work, then we have to manage the fault. So we have to determine the root cause and then we have to fix the issues. Security management, as we know, the data is our personal data and we have to make it possible to make the data secure. So for that purpose, we have to do the security management. Only we have to authorize the persons that is inside our organization. No unauthorized person will be allowed to use that network, so our data must be secure. Since an IT network is critical to business operations, it is imperative to ensure it's protected from various network-based threats. Like banking systems require the most security management because they have sensitive data. Our forces need the security management properly because they also have the sensitive data. So the network administrators can use firewalls and monitoring tools to help to ensure the network is safe and the attacks are identified and blocked quickly. If any unauthorized person is trying to get the data from our network or trying to enter inside the network, we will block that person. So what are the network infrastructure solutions? The network infrastructure solutions are designed to solve the specific problem in the networking, like according to different scenarios, we can solve that infrastructure. For example, a firewall solution may be available for different environments such as on-premises, virtual machines, and cloud-based firewalls to address the security needs of a specific IT network. So a firewall is a network security device that monitors and filters incoming and outgoing network traffic. Like a guard is placed at the gate and it will check each and every identity. So in same case, we installed a firewall that will ensure that no unauthorized person will attack over in network or access over network. So it's the most basic. A firewall is essentially the barrier that sits between a private internal network and a public internet. So a firewall's main purpose to allow non-threatening traffic and to keep the dangerous traffic out. So that is a scenario. So a firewall can protect over private network from the hackers. Now, advantages of computer network. There are a lot of advantages of network. As we discuss the file sharing, we can share our files, resource sharing, we can share over multiple devices such as copiers, printers. We can make the communication from source to destination. Convenience in that data is accessible through an internet connection, so there is no need to send over data in the physical files, or we don't there is no need to copy a file and use the USB and send that file to another computer. Within seconds we can, by sitting at our own computer, we can send over data, so we have the convenience of sending the data. Cost in that there is reduce the hardware cost, like there is no need of a personal printer for a person, every person. We can share that printer along with the multiple persons. Storage, one, as we can share the storage, so we can use a centralized storage and every person can utilize that storage. Why the network infrastructure is important? As your company grows and the amount of data traveling across your corporate network increases, the foundations of your network get put under the stress. So we need the planning, and we must know which devices are better, which protocols are better, and which topology must be followed. So for that purpose, we must work on the network infrastructure, because internet and the marketing, social media, that are essential part of now our business nowadays. So maintaining your network reliability as so as to avoid the costly downtime indicates our worst loss data becomes more and more important. So we have to provide a stable connection towards our persons. So we have to make our infrastructure better. So if a disaster were to strike, your company having a reliable and well supported network will make recovery much easier, because we are working on the backups also, and we are working on the cloud computing. So if we lose any type of data, we can recover that data by using the internet or the network if we have worked on the network infrastructure. In an age of remote work, as a result of coronavirus, your company's network is likely under more strain than ever before. So, as we all know about that scenarios at that time, we all was doing the remote work. So, we now we can understand the need of the internet and remote work. So each or during which your network suffers issue is an or where your entire business grinds to the halt. So like in e-commerce, in banking sector, if you are unable to provide the internet services or your application services, you can lose your clients. So making forward-looking investment into the critical but often forgotten infrastructures pay dividends in the future. So we have to make infrastructure stronger. So how does network infrastructure impact security? As we know, when our data is available for the common person or for every person, there are some concerns of the security. So an outsized propagation of your company's network infrastructure serves to protect the network and endpoint devices from the attack. So whenever we have the multiple clients, it will be more difficult to give them or provide them the security. Whenever it's your firewall stopping unauthorized traffic at the edge, or the network security appliance detecting and preventing and in progress malware attacks, network hardware, software, and services are all a big part of your company's cyber security. So we have to hire or use the different security systems, and there are different algorithms are included to minimize the security attacks. So in particular, business commonly connect their detection systems directly to the firewall so that they can stop the attacks as soon as they are detected. So in similar manner, logging and management systems can be connected to the other infrastructure to provide the oversight. So we have to make it secure as much as we can do. Is there any issue in the lecture?
No,
Okay, then take care. Have a nice day. Allah Hafiz.